Audio Jungle. Audio Jungle.
All right, so we'll talk about the moment of inertia. Moment of inertia formula and that theory of moment of inertia I had given last lecture. Now here we have to see the how to calculate moment of inertia for different sections. So first section I am taking, that is MOI, moment of inertia. Okay, MOI, moment of inertia of rectangular section, right? So rectangular section, I can take here this rectangular section is what, something like this. This is the rectangular section, and here if you check for this rectangular section dimension, here it is given. Dimension is nothing but, we just say this is the width B, and depth, or you can say height, better to say height, it's nothing but h, right? Now we are interested to calculate moment of inertia about any section, about any axis, you can say. So we'll talk, two axes will have, obviously this is the vertical axis, which is nothing but y axis, and this is the horizontal axis, which is nothing but x, and this is what, y, right? So here first we'll calculate about x axis, and then obviously I will teach you directly how to remember for y axis. Anything you can do, you can calculate for y axis, and x axis you can similarly you can write. So better first I will take about x axis. Okay, now, so we can say the moment of inertia about, moment of inertia about axis xx, which passes through centroid, because this is the area section we have taken. So this is the area. So I had explained you, if area section if you take, and if you assume the concentrated uh, of that area one point, so that concentrated point assumed as a centroid. So this is nothing but centroid basically, right? Right. Through centroid we'll take an element somewhere. We can take take an element here. uh, I can take one element here like this. This is the one strip we have taken, and obviously vertically it is considered as y, so this is nothing but dy. uh, this thickness is nothing but dy, and positioning of this strip from the centroid is nothing but y. We have taken this thickness of strip is what, dy. Okay, so or thickness, or we can say a width. So strip dy I will write here, otherwise strip dy is the stripped width. Okay, and it is distance y. Okay, uh, y is the distance or positioning of strip, distance of strip from xx axis. All right, now it is clear. Now if you see for this strip, what is the area of this strip? area of strip. What is the area of strip? See, the strip width is nothing but b, and this is nothing but dy. So what is the area? This is the strip basically. What is the area here? It's nothing but dA. So it's nothing but b into dy. Simple, b into dy. Now you know very well, last lecture also I had explained, if you calculate moment of inertia of the of the element element about x axis, okay, then what was the moment of inertia? I had given ixx. If you remember, I had given ixx was, it was integration, and if I took xx, then it will be y square dA. That last class I had given only. Okay, now if you see, so what is the ixx here? It's nothing but y square into dA. What is dA? Just now you have written into b into dy. B into dy is nothing but area, right? Now if you check, this strip this strip can move, uh, because we have taken at y distance from the axis, but this strip can move from position, you can say this is a, b, c, d. So this strip can move from AB to CD. Vertically it can move AB to CD. Yes, it can move. Yeah, no doubt about it. It can move. Otherwise, also you can write, you can take, because you have taken one x axis which is passing through the centroid. So half portion you can take. This half portion is what, h by 2, and this half portion is h by 2. That also is possible. You can write, it's your choice. So downside from the centroid is nothing but minus, and upward side it is h by 2. So downside it is h minus h by 2, upward side it is h by 2. So if I take the limit, so what I can take, minus h by 2 to h by 2, means I'm taking this x axis which is passing through the centroid is now my reference axis. And now if I integrate this strip, like how it can move. So I told you this strip move vertically from AB to CD, it can move. Okay, so total length, if you check, it is h, x axis which is passing through the centroid. So upward side it will be h by 2, and downside it will be h by 2. So downside, you can take negative sign because it is below the reference line, and h by 2 upward side it is positive. So this will be the limit. Another way also you can write, you can make two times, because this is the half portion. So you can take uh, two times of 0 to h by 2. That meaning will be same. 0 to h by 2 you can take two times, so that meaning is same. So this is nothing but b is common, which is constant, and it is y square dy, right? We can take like that. Now if you integrate, so what you will get? Ixx, b you take outside, so 2b you took outside, and if you take integration y square dy, so it's nothing but y cube by 3, right? It's y cube by 3 here. Now you take the limit 0 to h by 2, so it's nothing but 2b by 3. In limit if you keep, then it is h by 2 cube, right? All right. Again, if you see the calculation, so it's nothing but ixx is equal to 2b by 3, and it's nothing but h cube by 2 cube, which is 8, right? If you solve it, then it is nothing but, I think, b h cube by 12. So what you got? You got simply, suppose this is the rectangle. Now we just focus. So in this way you have to remember onward. This is the rectangular section you have taken. This is what B, and this is what full length is what H. Your axis is what somewhere here. See, this is the axis which is passing through the centroid, x-x axis, and this is the y-y axis which is passing through the centroid. Okay, remember, condition is when axis is passing through the centroid. Then if you want to write Ixx for this, so just now you have derived Ixx is you got bh cube by 12. But similarly, can you write for Iy also? Yes, you can write. Similarly, how you can write? My Iyy will be, see, you just check Ixx, what you have done. If you are taking Ixx means xx axis is what cutting to the height. X-X axis is what cutting to the height, means it is cutting to the h. So once it is cutting to the h, so h cube will come, b into h cube by 12. Everything will be same, only we will talk about bh, and 12 will be same in denominator. So here also I can make it 12 same. Once x-x axis you are taking, so x-x axis is what cutting to the h height. For that reason it is HQ. I'm telling you the technique how to remember. Otherwise you can go for the derivation just like Ixx I have derived. Similarly you can go for derivation YY also. It's not a big deal. Okay, it's not a big deal. Here you have to integrate from minus b by 2 to b by 2. Rest everything will be same. It's not a difficult. It's very easy. I'm saying for how to remember. So Iyy, you have to take denominator 12 as it is. Now, if you go for the Iyy, so a yy axis is cutting to the b. So you have to write b cube. What is the left dimension? It is h. So hb cube by 12. That is Iyy, right? If you are talking about xx axis, so check xx axis is what cutting to the h section. I can write here. Your xx axis is what? This is the h. So your this dimension is nothing but h. This is the technique only I am saying. But if you draw the x-x axis, so x-x axis is what cutting to h height, hence it is h cube, and left dimension is b as it is. Similarly, if you talk about Iyy, so yy axis, see, this is the yy axis, and here the dimension is nothing but b. See, this dimension is nothing but b here. Concentrate now. This is what? B. So this dimension is nothing but b. But if you take y axis, so y axis cutting to b, hence it is b cube, and left dimension is h. So automatically it is now very clear like how to remember. Rest every different section we can write in the same way. Like for rectangle, you got section, suppose nothing but b, and this is nothing but h. So if you talk about both axes, xx, and this is what? Yy. So my xx value will be, it will be xx value will be bh cube by 12, and Iyy will be, it is hb cube. You need to remember this, right? You need to remember. And suppose it is asked polar moment of inertia, which is nothing but Iz. Suppose it is asked, then what is the Izz? Izz is nothing but J, polar moment of inertia, which is Ixx plus Iyy. Last class I had told you. So Ixx is nothing but what? 1 by 12 in bracket bh cube hb cube. This is what? Izz, which is also called polar moment of inertia. So this is for the rectangular section. We can take different section in this way. Okay, I can take suppose a square. So this is now square. Square if I want to write. So square means from all side dimension must be same. So doesn't matter what is the dimension you are taking. It's A here, A here. This is also A, all side, right? Okay, now if you are interested to write the XX and YY, so what you will do? It's a simple. You can take axis will be what? Similar, you can in the same way you can apply like BH cube by 12. So width is what? A, height is what? A by 12. So ultimately you understood I axis is nothing but A to power 4 by 12, and similarly IY is nothing but A to power 4 by 12. Huh? Same way. So this is for the rectangular section, okay, for XX axis and for YY axis. Formula you need to remember, right? Now this square is what? On base, but this square also we can keep on diagonal side, square area with diagonal as axis, or we can keep on the corner also. Once you keep on the corner, so how that square will be there? It will be, now this is the, it's a diagonal, one diagonal will be axis, and this is now square. Okay, see, this dimension is nothing but A here, A here. hmm, what you have taken, this is also square, but square area with diagonal as axis. Where is the diagonal? See, this is the diagonal. We can say diagonal is what? On one axis. This is x axis, and obviously vertically you can take, this is the vertical axis. So diagonal is what? Axis, on axis. It may be x axis or y axis. If this case will happen, then what is the I axis? Because it's a square, so obviously the same thing you will get. Doesn't matter. Okay, maybe this type of square and this type of square, both cases I axis and IYY will be same, right? Now coming to the a circle. Okay, coming to the circle. So moment of inertia, that is third case, MOI of circular section. Now, so for circular section, derivation is not required actually. So we can draw the circle something like this. So for circular section, if you want to calculate that moment of inertia, so circular section we can take, this is what centroid, from the centroid axis is what passing, just like this, YY axis. Okay. And if you check the diameter of this circle, so diameter will be capital D. We can take this. This is the capital D, which is nothing but diameter. If you want to get the moment of inertia, so we have to take one strip here, just like a rectangular section we had taken a strip, so here also we have to take a strip something like this. And if you check the radial thickness, so this is nothing but dr, right? If you check this ring, I can take this ring outside, so this ring will be something like this. This is the ring, one element, circular element we have taken. Okay, this is the circular, just like a rectangular element we had taken one strip. So here also we have to take one strip. We can say this is the center, and from the center radius is what? R, and this thickness any side you can take. This thickness is nothing but dr, means this radius is what? Small r, and this thickness is nothing but dr. That is my point. Now you are interested about the polar moment of inertia, because I told you that time also, if you are calculating for the circular cross section, so if it is on xy plane, so for circular cross section moment of inertia will be perpendicular to xy, that is z axis. And if you talk about the z axis, so obviously it will be the polar moment of inertia. So always remember this, okay, always remember this. So j is nothing but the polar moment of inertia. Polar moment of inertia, okay. And you know that how to calculate this, it's nothing but izz. Izz is nothing but j, and if you check, it's nothing but ixx plus iyy, right? Now coming to the calculation of it, so you will have a j, which is nothing but polar moment of inertia 0 to r, because the full radius will be, the full radius of this complete outside circle will be capital R, diameter is capital D, okay. So 0 to r, and it is nothing but r square. If you remember, it was r square dr, or you can say that is the area of ring, okay, area of uh, ring, r square into dA. When I had explained more polar moment of inertia of last lecture, then I had given this, it's a r square dA. Just like ixx, you will write integration y square dA, iyy, you will write integration x square dA. Similarly, polar moment of inertia or izz, you will write r square dA, where r is the radial distance, right? Now if you want to calculate, then this 0 to r square you can write, but what about this dA? dA is nothing but area of it. Once you open this strip, once you cut somewhere, once you open this strip, then what you will get? You will get a strip something like this, huh? And if you open this, then what you will get? uh, if you expand, then you will get the circumference. And what is the circumference? It is nothing but 2 pi r, this is the circumference. And what is the width of this strip? Is nothing but dr. So what is the area? Area is nothing but 2 pi r into dr. This is the area, simple, right? So your izz, which is nothing but polar moment of inertia j, and its integration 0 to r. Now you can take 2 pi r cube dr. Done. Your derivation is done now. So here, if you check j, polar moment of inertia, which is 0 to r, and I have 2 pi r cube, 2 pi r cube dr. We can take 2 pi common, constant outside, 0 to r cube dr. Now you just solve 2 pi, just keep the limit, it becomes r power 4 divided by 4, and it's 0 to r, right? Now coming to this, we'll solve it, then what value you will get? See, 2 pi r to power 4 divided by 4, this is the result. You can say pi r to power 4 divided by 2. This is the polar moment of inertia. You can convert into diameter also. So it is pi, diameter is nothing but r is equal to diameter by 2, and this is 4, and divided by 2. So what is the value? It is pi in terms of radius, pi r to power 4 by 2, sorry, pi r to power 4 by 2. This is one formula. Another, in terms of diameter, it is pi d to power 4. Denominator 2 to power 4 is nothing but 2 into 2 into 2. How much? 16, right? 16. That is the 16. And what is the value of 216 to 32? So this is nothing but j, which is nothing but pi d to power 4 by 32. This is the polar moment of inertia. Okay, this is nothing but polar moment of inertia. As you know, this j is nothing but izz, and it is nothing but ixx plus iyy. As you know, if the section dimension is what same, then value will be same. Just like a square, if you check, dimensions are same, ixx and iyy same. Similarly, this square also dimension are same all sides, so ixx and iyy value will be same. So similarly for the circle also, because everywhere the from the center radius will be same, So I-axis and Iy will be same. So you can say any value you can take 2Ixx is equal to 2Iyy. You can take like this because you can say here, you can say Ixx is equal to Iyy. So you can say Ix is equal to Iyy, then you can take 2Iyy, or you can take 2Ixx. It's your choice. So if I say what is the Ixx, so you have to say j by 2 or Izz by 2. Similarly, what is the Iyy? So you have to say j by 2 or Izz by 2, right? So what is j by 2? Just now you have calculated, it's a pi d to power 4 by 32 and divided by 2, so it becomes 64. 60. So onward, you remember for the circle moment of inertia about xx or for axis yy, if you calculate, then it will be same pi d to power 4 by 64. Don't get confused. Moment of inertia for xx and for y axis must be same, that is true, but polar moment of inertia also there, which is perpendicular to both. Okay, so that is nothing but pi d to power 4 by 32. Don't get confused. J, polar moment of inertia, this is very special. We'll use this in torsion. Okay, so you need to remember this also. This is called polar moment of inertia. J is nothing but polar moment of inertia. It's very special. Pi d to power 4 by 32. Right? This is for circle. Done. Now we'll go for the another section. One very special is what left. That is nothing but triangular area we have to take. So it's very easy also. Triangular area, which is nothing but 4 number. We can go for the triangular section. Triangular section. So for the triangle, we can draw. This is the triangle now. For this triangle, we can have base, that is width also. It's a B. Okay. And this is nothing but from here to here, it's nothing but H. We can have somewhere, this is what centroid, and from the centroid, suppose x axis is what passing like this. All right. Now if you want to calculate Ixx for this triangle, if you want to calculate Ixx, so what will be the value? It's a cutting to H, so you have to write BH cube by, remember, 36. But if it is suppose triangle, so it will be BH cube by 12. That is the difference. Derivation I am not giving because you just remember this. Also you can derive it. It's not a big task, but many sections we have, so better will not go for the derivation. So BH cube by 36 will be the Ixx value. This is for the triangle. But the job has not been done. Very special things, that is called all cases hollow section. Like again, we'll start from the rectangle section. Rectangular section I have explained, but rectangular hollow section I had not explained. Okay, so that I need to explain that also. I can say rectangular hollow section. This is very special because in problem that you are using rectangular hollow section. How rectangular hollow section will be? So you can see the rectangular hollow section means it's like check rectangular hollow section. It's nothing but outside dimension. I can say this is what H, right? and inside we can take this section, it's nothing but small h. This is small h. Similarly, we can take outside section, it is capital B, and we can say this inside section width is nothing but B. Now hope it is clear. In between this portion is what's hollow portion. This portion is what? Hollow portion. Okay, this is the hollow portion. Hmm? Right. Uh, Now coming to the this hollow section. So how I will calculate it? I will calculate it now. So moment of inertia of the big section minus a small section. So what is the moment of inertia for the big section? You can calculate. It's nothing but, if you are interested about x-axis axis, suppose I-x-x, it's passing through the CG x-axis. So what will be the I-x-x? So what is the moment of inertia for the big section? Because we are talking about x-x axis, so it is cutting capital H. So it's nothing but BH cube by 12 minus small section BH cube by 12. This is for the hollow section. Similarly, you can write Iy also. You can write Iy also. What is that? It is H B cube minus H B cube by 12. This is for the hollow section. Remember it. Okay. Now onward, we can take the moment of inertia obviously for the concentric circle, or we can say hollow section. It's your choice. So now for the circular hollow section also we can write circular hollow section. How to write this? Circular hollow means we can say this is the one circle and this is what? Another circle. Just correct it. Different color I want actually. Right. Now for this, diameter is big one, diameter is capital D, and for small one, for this small one, diameter is small d. Now suppose I am interested to calculate moment of inertia for x-axis axis. So I-x-axis is nothing but pi d to the power 4 64 minus pi d to the power 64, right? So, and obviously Iyy and Ixx both are same, so it's nothing but pi 64 d to the power 4 minus, this is Ixx and Iyy. What about J? That is polar moment of inertia. So J is nothing but half of this. It's pi by 32 d to the power minus, right.